Hello. Well, welcome back. Let's see here. Source PC output. Okay. I did figure out how to record presentations so that you can send them to me after you've done them, and I'll talk about that today a little bit. We'll talk about our next project today. We'll also need to talk about the end of our last project. So we'll start with that really quick. Actually, we won't. I'm going to start with a little show and tell. So this past weekend, in my more advanced engineering class, so then we have an Engineering 1000, which is this class, then we have Engineering 1010, which takes the concepts we learned in this class to a kind of a higher level, more real situation kind of engineering. And it's much more involved. We use more technical things, and we do more technical stuff. We do much bigger projects, and we learn more about how to be a real engineer. And so they did a full-size trebuchet project, and let's take a look and see if I can show you guys what we did. So here is one of the full-size trebuchets that we saw this weekend, 6 feet from the floor, from the ground to the pivot, and this arm was, I think, about, 15, 16 feet long, and about 300 pounds, 300 to 400 pounds on this weight on this end here. And let's see if we can see some other ones. So this is the same one. Here's another one that's about 6 feet high, and then the high school here in town also made one that's about 5.5 feet high to the pivot. And you can see here that they've got this cantilever arm, not a cantilever arm, but an arm here with a big hook on it for a weight, and they've got a pouch down here on some rope for throwing things with. And here we have our safety inspector showing them that their bar got bent in the middle because it couldn't handle the weight, and so he was trying to tell them how to make that better. The high school made an interesting one which used a cantilever so that the mass pulled it at different distances from their axis. Here's their axis here in the center, and then you have these different lengths of boards out here. So that was an interesting design. They weren't able to get it to work the way they wanted it to, but they were close to getting it to work. There's the high school team, great big team of high school students came out to do this with us. Here they are loading the trebuchet. This is the trebuchet that actually won the competition. They're loading the trebuchet with the pumpkin and the pouch there. It's just kind of tied in there. And then, let's see if we can't go to our movies. Let's see if we can't see one of these thrown here. Oh, come on. So let's see, what are we seeing here? I'm just looking at my desk, it looks like. So here we are. We'll zoom it out here eventually. Trying to look at them loading it. Loading their pumpkin in there. Kind of shaky. So they pull the pin out from the side. Looks like we're not even going to get to that part. Let's watch the next one. So there he goes. He throws the pumpkin. I ended up not watching it. Why didn't I watch it? I don't remember why. Let's do another one. I was busy doing lots of things. So here's our other team. They're going to throw a pumpkin here. Let's see how they do. They're pulling out a pin. I don't know what happened to my camera shots there. Need a better cameraman. Need to fire myself and hire somebody else. Here's one. So here they throw it, and the pumpkin went about 50 feet that time. Let's look at this one here. This is the best. This is I think this one is supposed to be of the other trebuchet. Through a bit further. I was actually helping other people do things while I was taking this film, so see how they throw it here. So they got that one thrown about 60 feet. The best one went about 200 feet. And if you want, I guess I didn't get a movie of that. I suppose my camera wasn't working for that one, but we had some video from the news people that got a video of them throwing 200 feet, so that was kind of exciting. And it's an event that we're going to try to do every year, so if you want to do it next year, put together a team and throw pumpkins out here in North Platte, you're welcome to join us. They also do this out in Arthur, but it's a bigger event out there, so anyway, we're hoping that we'll make that a bigger event each year and have more than just 3 teams come, and make it kind of fun throwing pumpkins around and smashing pumpkins. Okay, so now that we're done looking at that, let's talk about this project we're just finishing up, which is our little miniature trebuchets. Remember, I gave you all of these particulars in the email that I sent, where you're throwing, it has to be 10 inches or something to the axis. You have to make it with the parts that I give you, no elastic parts. You're throwing a 1/4 pound projectile, you're trying to throw it 20 feet. And when you're done and you're testing it, you need to make a video of it. You also need to take pictures of your building process and have a logbook of all the stuff that you did. Now, I've got some videos from people, I've got some pictures from people, but I don't have a lot of logbooks from people yet. So your logbook should be the notes that you took while you were doing this project, included, and should include your design drawings and your pictures. It should essentially be a diary of everything that you've done for this project, so that if somebody needed to redo it, they could redo it by reading this logbook. I need that turned in as well. And then the last thing that you're going to do is you're going to create your presentation. That's what we should have started last week, and it should be done, if not close to done, if not done today. I'm having trouble speaking today. But I did figure out how you're going to record that. So what you want to do is you want to go to PowerPoint, which is not that, PowerPoint, and you open up your presentation, whatever it might be. Let's say that we go to design engineering, for example, and you're going to go up to slideshow, and you're going to record slideshow. And you can record your slide and animation timings, your narrations and laser pointer if you want. I'm going to do both because I want to record my voice, my narrations, and I'm going to start recording. Now you have to have a microphone on your computer to record narrations. If you don't have a microphone, it won't record them. But as I'm talking here, you can see up here in the left-hand corner that it's recording. It's giving me 10 seconds. And when I was done telling you that my presentation is about design engineering, and my name is Jared Daly, and I'm doing this for Engineering 1010 at North Platte Community College, then I would go on to the next slide, and I would start talking about this slide. This is a description of what design engineers do. It covers multiple engineering disciplines, cover everything from electrical to architectural engineering and more. And design engineers are in charge of everything in a particular system, not just one particular part. They're designed of making sure everything works together. and they often are working with a team of other engineers that are working on the other parts of the machine, particular parts of the machine. And then I may go on to my next slide and talk about this slide. They have to deal with more complex technological systems like big transportation systems, freeway systems, train systems, aircraft systems. They have to deal with machinery, but not just one little machine, but all machines in an entire factory, and so on and so forth. I'll discuss each slide as if I was giving the presentation to a group of people with all the correct timing and everything else. And you can go ahead and use this mouse as your laser pointer. And then I go on to the next slide. I talk about this slide. Maybe I want to make sure that they understand what this process is about. Maybe go through an example. And I go through each slide, talking about each slide as if I was talking to a group of people. And I get to the end and I say, these are the resources that I used, and I'd like to thank so-and-so for helping me out with this, or thank the members of my team that worked on this project, and are there any questions that we might say at the very end. And then you're done with your presentation. When you're done, you can come up here and you can hit pause, or you can just close this thing. Either way, let's see. When you open up your, let's see. When you open up your presentation again, though, so let's say we open this up. You can see down here there's a little speaker thing in the right-hand corner, and that's your recording. So what it's done is saved a recording of your voice into your presentation. And then you can just go ahead up here to your home page and you can save your, or up here to your left-hand corner, you can save your presentation with that stuff in it, with all that stuff in it. And the next time you open up this presentation, it's going to go ahead and run it like that. So let's go back to slideshow, and I can just go ahead and start from the beginning. If I show the slideshow from the beginning now, it should actually have all that timing and that voice in it. Now my computer doesn't have a speaker on it, so it's not showing us any speaker, but it should change the slide here eventually for us, hopefully. Let's see if it actually does it. Let's see if I did it right. See? So now it's actually changing the slides automatically, and if I had a microphone on my computer, it would repeat back all the things that I said during this presentation, so that I don't have to say them again. And then if you're really good, you could lip sync yourself, lip sync your own voice. Anyway. So go ahead and to end this presentation, we can click through it and end the slideshow. But then this stuff is actually saved to your slideshow. You can actually click on this, and you can change things about it if you want to. You can erase it if you want. If you click on this and you hit delete, for example, it'll delete all those things that you saved in there. But you can also keep it in there and save it. So if I undo that and then I save this presentation with that in it, when you send me that presentation, you send me this file that has got this voice and this timing in it, I will be able to play it on my computer. And that's the idea. We want to be able to play those for everybody to watch during class. And so I need to have you send those to me. So, what is the bottom line? The bottom line is that you should have a presentation that is done or close to being done. And when it is done, you should run through the presentation using the record slideshow setting in PowerPoint. And you should save it with your commentary, with your presentation, you speaking and explaining the things on each slide that you did for this project to build your mini trebuchet. It should be at least a 5 to 6, 7 minute presentation, and no more than about 7 or 8 minutes probably, which means you're going to have at least 5 slides. And you should time it. If you get through your presentation, it only takes you 3 minutes to get through it. You need to add some more slides or add some more information of your talking during those slides. So that is the last part of this project, is to put together a presentation on what you did for this project. Record it and send it to me. Now I'd like to have those recordings by Wednesday, because I would like to start showing them on Friday. So get those recordings done. That is your next big thing. We are going to start a new project, so we have to talk about that project as well. But the thing that I really want you to work on is getting this presentation put together and recording it and sending it to me. Any questions about the presentation? Okay. Just to give you a little bit of a helping hand with that. If I was doing this presentation, I would start off with my my index slide or my content slide or whatever you want to call it. Overview, you can call it, or whatever, overview of your presentation. I would start with this slide right here, my overview slide. And I would go in a very logical order. I would talk about, first of all, what is a trebuchet, right? Or what is a catapult, or whatever it is that you built, right? And you could also include that with the history of siege weapons or something like this, right? So this is essentially a description of what is a trebuchet and a little bit of the history behind it. What is the engineering history? Why did they switch from catapults to trebuchets, for example? And then I would go on to the project parameters. What was it that I was supposed to do, right? Project parameters. So that would be what is the height, what are the materials I was supposed to use, what was I supposed to throw, stuff like that. What were the requirements, in other words, for the project, right? And you don't necessarily have to do these things, but you should do something like this. This should be kind of the idea that you're getting to. These things probably should be covered in some way, shape, or form. And then I would move on to my design, right? What did I actually do? My design process, maybe. And you're going to include things like drawings, pictures, websites that you went to, options that you considered, so on and so forth, right? And then I would go to building my trebuchet, or something like that. And then the second to last thing probably is the results or the testing, right? Testing results. And maybe you include also design changes, design improvements, upgrades, whatever you want to call them. Things that you did so that you could actually get that 20 feet down range with your quarter-pound projectile. And then you want to do some kind of conclusion or something like that at the end. Your conclusions would include stuff like, this is how many materials that I ended up using, and I was able to throw it to 28 feet, and I was able to accomplish all of this using just a few materials. These are your bragging rights at the end. You get a chance to brag about how good you did, or maybe you might have to, lament the fact that you didn't do so well. So, your conclusions at the end. But this is a basic idea for an outline of your presentation. And these are the things that should also be included in great detail in your project logbook. You should be able to pull this stuff out of your project logbook without even worrying about it. It should all be there. You're just picking and choosing the stuff you want to put in your presentation. So what do we got here? We got 1, 2, 3, 4, 5, 6, maybe 7 slides. Maybe you have 2 slides for history of the siege weapons, or maybe 2 slides for your design process, or whatever else. Maybe you have a couple of those subjects that take 2 slides rather than 1, but we've got 7 slides there plus an introduction slide, and it's no big deal, right? You also throw in a slide with your resources that you used. But make sure that you have some kind of an overview And that's what you start with, because this is what's going to tell you how to put together your presentation. You don't want to just start with slide 1 and slide 2 and slide 3. You want to have an outline, and this is a great way to do it because your overview is your outline. Then you can go back and you can do all the slides for these separate things. And then the last thing you do is your title slide and your works cited slide. Most people spend so much time trying to get their title slide looking so perfect, and then all the rest of their slides look like crap. Not a good way to do a presentation. If you want to spend a lot of time on a slide, spend a lot of time on the slides right in the middle that talk about your project and what you actually did. My design process, building my trebuchet, and testing my trebuchet. Maybe some extra time on conclusions, but that's where you want to spend your time, is on the stuff that you actually did. Everything else is extra to that. So, you have a presentation to finish up and to record, and so I will let you guys work on that. You have some time to work on that by Wednesday. Get that done, get that turned into me, send it to me by Wednesday so that I can play those on Friday for everybody. Now, what is our next project? Does anybody have any questions about the presentation here? Okay. About this overview. Okay. So let's talk about our next project. Our next project, according to our syllabus, I believe, is, let's take a look. I'm pretty sure it's the motor project. Let's check it and make sure. Syllabus. So we are now at, this is October 20-something, 27th or 8th or something like that. 28th. So it's the 28th of October, and we're starting a radio project. It looks like we're doing motor project later. I think I'm going to switch those around actually really quick. I think we're going to do the motor project first because it's kind of it's a simpler project, and we're going to shorten it up a bit as well. So let me change this around here. Move the motor project up to here, and we'll move our radio project down to here. So our motor project is going to go on this week. It's going to be done by Friday. So you have a presentation due on Wednesday, you have a motor due on Friday, and the motor project is essentially build an electric motor powered by a battery. Nothing bigger than a 9-volt battery, and you're allowed to use one battery, right? Okay, so, but what's the project idea? Again, you're allowed to use parts that are in your kit, and yeah, I think that's about it. You're allowed to use parts that are in your kit and a battery. You can, I don't know if I provided a battery in your kit or not, but if I didn't, you can use whatever battery you want. And in fact, you can use whatever battery you want, but it can't be anything bigger than like a D-size battery. You can't use a 9-volt battery, one of the square batteries. So essentially, you're restricted to your AA, AAA batteries, C-size batteries, D-size battery, and you can use one battery. Okay, and you've got wire in your kit. You've got wood in your kit, screws and nails, and should have some magnets in your kit. Those should have come in your kit somewhere as well. Your job is to create a motor that will go as fast as you can make it go. And I'm also going to look at originality in the design. So essentially, 3 things we're going to look at. It's going to be made of the stuff from your kit. 4 things we'll look at. Made from the stuff in your kit. We want it to work, so it should spin in some way or move in some way. You want to try to get it going as fast as you can, and we're looking at originality of the design as well. But many people might say, I've never built a motor, I have no idea how they work. Well, that's what we're going to spend some time learning about today is how motors work. Motors are really quite simple. They use a combination of electricity and magnetism to create movement. And there are literally thousands of different kinds of motors, but most of them are all of the same variety. So let's take a look here. You can go on to google.com and you can type in electric motor, and probably you want to put in something more than just electric motor. So for example, electric motor build, or electric motor homemade, or electric motor DC, which means direct current, which means you can use a battery. And you can go on here and you find thousands of websites and lots of images and everything else that show you, different ways that motors will look, and different designs of motors, and different real motors in real life. Just so many different motors out there. If you put in electric motor homemade, you'll find all kinds of different designs that you could use in this project, and instructions for how to make these designs work. There's just a lot of them look the same, and a lot of them look the same because most motors have a very simple design that looks kind of like this, where you have a bunch of wire all coiled up into a circle over and over and over on itself. And then this circle is mounted on some kind of an axis, some kind of an axle. In this case, they actually use the same wire that they wound around and around and around to tighten up the wire and then to use as their axis. And then that axis, those two ends there, are connected to a battery by some wires somehow. And that is the basic design for just about any homemade motor. Here's another version where they use it looks like a couple of sewing needles taped together as their axis, and then they've got a magnet down here. Notice that they all have magnets as well. This one has a magnet down here in the wood. This one has a magnet sitting on the table here. This one is interesting. You can't really see it because it's small, but it actually uses paper clips to hang this little loop of wire from the battery. Uses a 9-volt battery, which I'm not allowing you to use, and then they just hold the magnet there. This one uses 2 loops of wire. You have 1 loop of wire down here, which actually is creating the magnetic field. That is your magnet, it's an electromagnet, and then this is the wire up here for the motor. This one uses a bigger battery, some kind of D battery or C battery. But see, there's a magnet down here, and there's a loop of wire. But there is a trick to this, and you have to understand a little bit about electromagnetism to get the trick right. And the trick is that you need to change the current, the electricity. You need to change the direction of the electricity through the coil every time it flips around. And in order to do that, you're going to have what's called a commutator. And so we're going to go learn about what that means, what that's all about, in maybe 10 minutes or less. So we want to look up some animations for motors. This one looks good. Let's see if it works. All right. So these are interactive animations that help you to learn about physics situations, physical situations, and so on and so forth. And what we've got here is let's see if we can make this work. Blocked for security reasons. Goodness gracious, you've got to keep. All right, let's go to. Let's go directly to the website, I suppose. Okay, let's see if we can find this one again. Oh, come on. Where is it? Where did it go? Why can't I find this? Where's let's go to DC motor. Motor. Dang it. This is giving me fits. Alright, we're going to have to find one of these that works. Why won't it just play it from the computer? Dirty bugger. Why is it giving me so much trouble? Alright, we're going to have to try a new one, I guess. Let me try a new one here. Let's try this one. See if we can get it to work. No. This computer is not updated enough to do this stuff, and I have no power to fix it. So what we'll do is we'll just look at this picture and imagine that it's moving. We'll imagine that maybe we'll be able to watch a video on YouTube or something. What we got here is this is our loop of wire, or a coil of wire going through here, and you can see that over here it's connected to what we call our commutator. It's a split ring commutator. Notice that it's got a split up here and a split down here, so that the right side and the left side are not connected to each other. The right side is only connected to this side of the loop, the left side is only connected to this side of the loop, and their only connection is through this wire here. I don't know what I'm supposed to do with this thing. New call automatically answered. Hello? There's somebody calling me. I don't know what I'm supposed to do with that. Anyway, okay, so when we connect these two commutators to our battery, which is over here, we get a current going through this loop here. And the current actually creates a magnetic field that tries to line up with these magnets. And so it flips the ring to the side. When it flips the ring to the side, these brushes are going to be in the gaps. They're going to be in the split between the commutators, and they're not going to be connected to the wire anymore. But when this thing flips, it's going to rotate, and this commutator on the left is going to become the commutator on the right. And so it's going to connect to the battery again, but the magnetic field is going to cause it to flip again. And it keeps flipping it, keeps flipping it. And that's the idea of the commutator, is it constantly changes the direction that the current goes through this wire, because the wire keeps flipping around. And that's the whole idea, is to just keep it flipping by keeping those brushes switching sides. Now there's a lot of different ways to do that, and it's one of your jobs to go out there and find a way that works for you to make that work. Now let's actually go look on YouTube. Let's actually look at electric motor. Let's look at this YouTube video here. Let's see if it has something for us. 19 cents. So here you can see this thing is moving, and here's the connections. The red part is the disconnect. So it disconnects every time it goes around, and then it reconnects every time it goes around. And that's how it works. So this is a great video, a great resource. There's probably quite a few more videos on YouTube that you can learn about DC motors. Let's take a look at this one here. Maybe they have some talking in this one. I'm not hearing any talking. Here they're just showing it again. I'd really like to see them talk about it. Let's see if we can find one that talks about it so that we can hear it as we're... That's okay. But anyway, what happens is that as that current goes through, it creates that magnetic field in the wire, which causes it to rotate. And then when it rotates, it changes the direction the current goes through it. So it causes it to rotate again and again and again. And it keeps going around and around and around for that, because of that changing of the current direction of the current. Now, you might want to go here and say homemade motor. And say homemade DC motor or electric motor. And here they're going to tell you how to do it. And you can choose which one you want to work with. Yeah, the volume stinks right now.
DC motor like you have never seen before.
Wow, this guy.
I actually started this DC motor back when I was 12 years old. Never got it to work. You've never seen before.
This guy is going to put me to sleep in the first second, so maybe we want to look at a different one.
DC motor project we've been working on.
So this one's got a lot of materials in it.
This weekend, just finished the windings on the core, on the armature.
Notice here he's got two copper plates, which are going to be his commutators, right? Those copper plates are connected to the coils over here by some wires, and he's got a bar of steel through these wires, which is going to actually increase the magnetic field. It's going to make it spin faster. But you also have to realize that it's also going to not only going to make it spin faster, but it's going to make it harder to spin because it's heavier. So there's a little bit of trade-off there. But he's got a bunch of magnets here. I believe that these are his magnets over here, possibly, or those are bolts holding his magnets, one of the two. So there's some magnets in this housing here somewhere. There's this connection pattern.
Plastic tubing and a split piece of half-inch pipe.
There's his magnets.
On the stator are neodymium discs.
So lots of different, here's how to make a DC motor in 10 minutes, right? There's just lots of different things that you can do here. And so you're going to research these things. Don't just pick the first one you see. Look at several, because there's some interesting ones, there's some fun ones. And then you're going to come back on, what did I say, by Friday? You're going to come back on Friday, and you're going to show your motor. You're essentially going to turn in your motor. Yeah, you're not going to be able to turn it in, I guess. We're still going to have to do it like we've normally done it with a video and everything else. But I do want you to keep a logbook of this project. Logbook while you're doing research, logbook while you're building the motor, logbook while you're testing it, while you're improving it, while you're making it work, and then take a video of your best results at the end. So that is the next project. It is building an electric motor with the parts, with the pieces that I've given you. So I hope that that is good. Anybody have any questions about that project? Okay. We are ready to go to our next project. We're all done for today. So I'll see you guys later. And if you have any questions, don't hesitate to contact me. Make sure you get your presentation done. Make sure you get your logbook done for the trebuchet and get started on the motor project.